the 5 centers, the 5 M&T centers got together, which is Maytech, NAC, NanoLink, NETEC, and SCME. We got together in Albuquerque. That's why the balloons, and a nice actual graphic by Matt's people. So we had a conference, and we actually had a solicitation, and we had a lot of people apply for that, and we had to turn some people down, unfortunately. And we had, I think, about 80 people or so attend that conference. The conference objectives were resource sharing and community building in this MNT, and then this basically was preaching to the converted. So we were working with them and trying to show them the resources that were at different places. We got feedback from that conference, and we had some very good feedback from a standpoint of the people that did attend. They didn't want to reinvent the wheel. They want to make sure that they're utilizing the materials. That's what we're there for, to show them what's out there, and hopefully they'll be able to take what we have and be able to adapt it into their classrooms across the country. And they really liked the hands-on demos, the online support, and that we were, that I like the last one, the best nano event / conference I've ever attended. So hopefully they've attended more than one, and that wasn't their first. But one of the components of it that we did during the conference was an NMT forum, and it was really getting people's voices into the room. They got a chance to voice their questions, concerns, issues amongst each other and amongst the other people from our centers that helped out to facilitate that. Basically to share what they have learned with other people who may be in the same position as they are, or slightly behind them, slightly ahead of them, and actually I think it worked out very positively. And we really are encouraging networking and further partnerships among those people who are integrating micro and nanotechnology into their curriculum. This is built upon, and I don't know where it is now, the actual forum was built upon the 5 pillars let me make sure I get this right, 5 pillars requirements for a successful and emerging technology program. Article that is actually in the process of being, it's actually in the draft stage that Deb Newberry has written. And those 5 pillars are not surprising to anyone in this room, I don't believe, but actually it's a really nice foundation upon building a program or integrating micro nanotechnology into a program. And that you obviously need to have industry support, faculty support, administrative support, facilities, and students. Students are really important. Industry is really important. You got to have jobs. You got to have some place for them to go. So it's important to let them know that you're there, and then actually to bring the students into the program. So we had topical groups in each of those areas. Now what we're going to do is talk about providing some answers to several of the commonly asked questions in the MNT educator community. And actually the way we're going to do that is by kind of going center by center, okay? Now I have enough time to go through my stuff, right? Good, okay. That wasn't 2 minutes total. Thank you. Told her she's got the taser. She's ruthless with that taser. So I'm going to talk a little bit about the National Center for, National Nanotechnology Center for Applications and Career Knowledge. And I'm going to answer one of the commonly asked questions in the MNT community. Where can I go for assistance in developing a full nanotechnology program at my undergraduate institutions? Not surprisingly, a good place to start might be with NAC, okay? And as I mentioned, we're based at, we are the National Center, ATE Center in Nanotechnology, and we're based at Penn State, and we have a sharing program with the schools in Pennsylvania. We evolved out of a sharing program with the community colleges and baccalaureate schools in the state of Pennsylvania. We enable education nationally now across the nation at 2-year. Our mission through NSF is to enable nano education at the 2-year community and technical colleges and 4-year universities and colleges in partnership with those community and technical colleges. So what do we have? We have a suite of 6 sophomore level courses that we've been teaching for about 12 years. They're 18 credits. We teach synthesis, fabrication, characterization. They're taught in either the 3rd, 4th, or 5th semester of 2- and 4-year programs across the state of Pennsylvania, and they're taught elsewhere in addition. They're industry-driven. Since 1998, we have an industry review board. We had a local board. Now we have a national board. We use a central facility model, and what that means is the students come to Penn State for this 18-credit experience, basically. And that's what we advocate as a good, efficient way to do it. But there are other models out there that can and do work. We have about 675 completers to date. Actually, I think after next week we might have 679 to be exact. We have about 40 students this summer taking this capstone semester. And we have about over 125 graduates companies, I should say, in Pennsylvania that have hired graduates. Just to show you, it's not just in one discipline. Nanotechnology is ubiquitous. It's across different disciplines. I just want to show you this graphic to show you that the degree programs in Pennsylvania, there's now 51 degree programs, and they're in just about any science or technology discipline you can think about. And that's where the students that make up our cohort of 40 that are there this summer, they come from almost all of these different disciplines. They come to our capstone semester, so they're basically a melting pot of students, and the commonality is getting the six courses during which they learn these skill sets, or should learn these skill sets by the time they leave that program. And as I mentioned, they're in synthesis, they're in fabrication, they're in characterization, they're also in the soft skills, if you will, from a standpoint of professional skills like presentation skills and keeping notebooks and some of the things we talked about that we heard yesterday, if you went to the student forum, some of the things that were learned there that are really important when you get out to industry that get them out there to hit the ground running. So this graphic of how it works. These are the academic institutions. This is how it works in Pennsylvania. These are the academic institutions. This is our local industry advisory board in Pennsylvania. And this is a graphic. It just shows where some of the students are employed. It's not even up to date right now, but this is about 75 of the companies, and then now we have over 100 companies there. But you get the idea; they're all over the place, and they get the training there, and then they go back to their home communities and actually go to work, basically. The portal, you want to learn more? This is the punchline, is nanoforme.org. We've got, you can actually get the educator resources there. You can get resources in many different areas. Like in post-secondary resources, you can get all of the lectures and laboratories in addition to videos of all the lectures that we give are all available there. We do educator workshops. We do webinars through Maytech. We do remote access to our tools. We'll have a session next. We'll be doing a session more on remote access the next session. K-12 resources and interactive multimedia. Won't go into detail, just don't have time to do that. 2 minutes. Thank you very much. I think I'm on track. Faculty development. Want to let you know this is a really important component. We do hands-on introductory workshop for educators, kind of for bringing people that maybe you or others at your institution want to know more about it, and they really are interested. We want serious people there, but they want to know more about nanotechnology. Well, they can apply to come to this workshop, and we do have funding available to bring them there. And it's a 3-day workshop. We also offer 4-day workshops, 2 different 4-day workshops on how to implement the courses that I was just talking about, how we do it, and maybe how you can then evolve it into your institution. We've trained almost 1,000 educators from all over the country and outside the country also. And then this is our schedule for this year. Again, we have a handout downstairs at our booth. Next workshops are coming up. We have one in September, one in October, one in November, and one in December. One in September, October, November, in November, I believe. There's 4 more workshops this year. The other things that we have, I'm not going to talk about, is an alumni network of all the people that are graduating for programs across the country. We want to keep them in contact. We have social media we're working on with that, and it's growing, and I think it's going to be something that's going to be very positive because we want to integrate industry with the current students, with the alumni, and also prospective students. And this is just a snapshot of where the different institutions that are institutions or the states in the country that have nano programs. The dark green is where they are, and the yellow is where I believe things are developing. This is Bob's view of the United States. So correct me if I'm wrong. If you're one of these states that's not yellow or dark green, if you do have a program or developing a program, please let me know. I'd love to hear about it because we actually want to link to it from our website. And I think I am done, and it's Deb's turn to take over. So Deb Newberry of NanoLink will take us to the next question.
Yes.
There you go. So you have to talk in there. There you go.
Thank you. Thank you. Thank you. It's a pleasure to be here. And one of the things that Bob mentioned was if you want to create an entire program, and NanoLink certainly offers entire program content. We have a 72 credit 4-semester nanoscience technologist program. Of those 72 credits, 43 credits are nano-specific courses and labs. And so we are more than willing to share what we have with you in terms of course materials, syllabi, whatever. Again, just like NAC and Penn State and NanoLink, we work very closely together. What I wanted to emphasize here was the approach that NanoLink is taking is more of a topical module approach to nanotechnology curriculum. Based on that line graph, that bar graph that Bob showed in terms of the multidisciplinary aspect of nanotechnology. And nanotechnology is not its own discipline, as probably all of us know. It's an enabling technology, and it impacts biotechnology, materials science, environmental science, quality assurance, manufacturing, many, many different disciplines. And so if you have a program that is in something other than nanotechnology specifically, and you only want a few snippets of nanotechnology, you know that crystal lattice formation, or you know that quantum dots, biological quantum dots are an important aspect that you'd like your students to know. NanoLink is serving as a place that you could come to pick up a small contextual package. And so the question that I want to address is if you only need a few of the topics of nanoscience to integrate into your program, but you don't want to spend the next 3 weeks surfing the internet trying to find test questions and activities and simulations and PowerPoints and all of those type of things in a reputable manner. So NanoLink is intending to fill that gap of being a one-stop shopping center for contextual modules. NanoLink is a regional center. We have partners in the states shown up here. We also, again, our mission, you can read it, is to enable community colleges, industry, four-year into their programs. Our initial starting set of 106 modules, topical modules, of which about 15 are completed, involve materials, electronics, and biotechnology, as well as let me go back. In terms of creating each module, one of the things that I'd that we not only are including the basic nanotechnology concepts such as sense of scale, surface area to volume ratio, material properties, how they change dependent upon scale, but we're also taking into account what used to be called the soft skills, the skills that the NSF now refers to as the 21st century skills, those things like working in a team, being able to lead, critical thinking, lifelong learning, all of those aspects of training a technician, of involving a student, of training a student are embedded into the modules that we're creating. We're also creating the tie-ins to the traditional science, physics, chemistry, math, whether it's a correlation to traditional high school educational standards or at the college level helping for example, college-level physics instructors figure out where in their curriculum they can integrate nanotechnology into that curriculum. And so we have multiple different applications, again, for the modularized content. And I keep saying module, and what in the heck is a module? Well, basically, we're defining it as a topical entity that will take approximately 3 to 5 hours of class time to complete. It's up to you, the instructor, to decide which pieces of that module you would like to implement. More than likely, most of the modules have more than 5 hours of content in it, But again, you can tailor it to the educational level of your audience. You can use demos. You can simplify the demos and just as an instructor do the demo, or you can have your students do the activities. We've got experiments, validated simulation, different topics for discussion, as well as questions and answers that are appropriate for quizzes or tests. One of the other things that we do is I kind of call it a internet scavenger hunt, but it's a way for students to work together in teams, a series of questions that are posed to them that they have to go to the internet and try and find the answers to. Like, what is the strength of the cohesive force in the bonds in a water molecule? Okay, thank you. So what we did was, as I mentioned, our partners started out with entire courses, 16 weeks of courses. We picked nanomaterials, which was traditionally built into 4 units, covered a semester of community college education. We took those units and broke them into topical modules. And so I wanted to show you this just so you could get a sense of the type of categories that we're looking at. Now, obviously, some of these modules or topics actually can get broken down into more than one module because it's certainly going to take you longer than 5 hours to cover some of these. And again, this is just another pictorial. If you don't like lists, here's a graphical representation of all the pieces and the tie-ins, the correlation that go into the modular content that we're trying to develop. Now, before I switch, the other thing that I wanted to mention, Bob talked about the meeting that we had in Albuquerque and that forum where we divided people into those 5 pillar groups. And if you wish, you can sign up. I'll send you that paper when it's done, hopefully in the next couple weeks. I still have to put conclusions and references in it. I have examples of it if you want to look at it. But at the forum, we talked about those 5 pillars, and we got together and we said, what are the issues? What are some of the solutions? And we had a methodical process. Bob and I are very step-tight people, and we walked the audience through deciding what were the primary issues within each one of those areas, and then coming up with what are the top 2 solutions. I have copies. They're slightly eye charts, but I was trying to save trees. But what we've done is we've summarized for each one of those the top 2 issues. For example, in industry, these were the top 2 issues that the group came up with and the top 2 solutions for each of those issues. I brought 20 copies. If you need another copy, let Bob or I go to NanoLink, go to Nano for me. We'll get you copies. So with that, I'm done. Thank you.
Thanks, Deb.
You're welcome.
There we go. Let me get organized here. Yeah. I'm Matt Plyle. I'm the PI on the Southwest Center for Microsystems Education. We're in Albuquerque. That's where we had our first MNT conference. It's a lot of fun. We learned a lot from each other, and we'll be doing another conference at Penn State in May. So keep your ears open for formal announcements of that. Okay, our goals is to become the authority for microsystems education. So we deal with things that are about an order of magnitude or 2 bigger than what these guys deal with. But nanotechnology enables microsystems and vice versa. So it's a very synergistic relationship that we have. So like the other centers, we want to support the growth and enrichment of technician education programs, provide professional development opportunities, and of course create and disseminate educational materials and models. So we do the classic educational materials as well as some really unique things. We have educational modules that are divided out. Each module has a primary knowledge SCO, which stands for Shareable Content Object. Activity SCOs might be 1 activity or might be 3 or 4 activities. And then we have assessments as well. So teachers can, as Deb alluded to, with her materials, teachers can pick and choose what they want to use. We also provide PowerPoints, animations, streaming lectures. I do a lot of these things online for my courses at the college. So, those things are available as well. And I'll help you implement it at your school. We do have a Moodle site, so you can actually create your own course with our help, and then you can manage that for your students. So what kind of topics do we cover? We cover, of course, microsystems, MEMS application, fabrication methods, clean room safety and protocol. We do have a one-week clean room workshop for educators where they learn how to make a pressure sensor. We have materials, topics on material scale, biomems. We have a suite of biomems which the subject matter experts came from Foothill Community College and Austin Community College helped us with that. And we have a really nice series of modules on the Wheatstone Bridge and transducers for those of you who teach electronics and want to evolve into the microsystems world. Okay, we do workshops, half-day, full-day, 4 to 5 day workshops. We do conferences and those sorts of things. But what we really like to do are kits. We want to take what you learn in the clean room and the concepts of microsystems technology. We'd like you to take them into the classroom. So this is a microsensor that we make in our clean room workshop, and this would be what you could take into the classroom to teach how a pressure sensor works with a Wheatstone bridge design and simple voltmeter and power source. So our kits, these are the kits that are currently available. LIGA stands for Long Involved German Acronym. We have the gene chip model. We have making of micro machines. I got to work with Ruth Carranza, who's here, and she made a wonderful film on MEMS, and I had the privilege of working with her on that. We have crystallography, rainbow wafer, dynamic cantilever, pressure sensor model, liftoff, anisotropic etching, pressure sensor process, and MEMS innovators, which is kind of a capstone kit as well. So all of these are available.
Do they cost anything?
They're free right now, but we're going to start charging for them soon.
So get your order in early.
Yeah. Go online. We have an order form that you can fill out. It asks you what you're going to use it for, when you plan on using it. And if you behave and use it and tell us about it, then you might get some more free stuff. The LIGA is basically a process of combining lithography with electroplating. So electronics uses a lot of electroplating. If you talk about electroplating, this might be something you want to look at. But this is a way of doing very tiny electroplating. Gene chip model, if you teach a bio class, and you want to talk about the technology used in the gene chip that are used to do DNA analysis and that sort of thing, we have a kit for that. And I'm not a biologist, but the materials are really good, and we had subject matter experts contribute to that one. Here's the MEMS making micro machine film. So we do have supporting curriculum that goes with the film. You can buy the film at Silicon Run and download the materials for free, or you can order a kit. Okay. We still have several free ones available. Crystallography kit, you learn about crystals and why they're important, and then we have a breaking wafer component where they actually break silicon crystal wafers, and the students have to figure out what crystal orientation those wafers are at. Rainbow wafer kit. These wafers are the same wafers looked at different angles, so you get different colors, right? So you can teach optics with that. The wafers themselves that we give you in the kit have stripes on them with different thickness oxides, so you can talk about etch rates, how oxide is deposited on wafers, and those sorts of things. So it's good for optics classes, it's good for chemistry classes, even physics classes can use these wafers, not just microsystems and electronics and that sort of thing. So we try to develop our kits so that you can bring them into a STEM classroom and try to show the students why you want to learn about thin film interference in your physics class, right? You use this in industry later on. Okay, that's good. I'm almost done. Dynamic cantilever kit. This is my favorite because I'm a physicist, but you can teach about materials with this kit. The relationship between thickness, width, and length or geometry on the resonant frequency of a structure. Cantilevers are used in microsystems and chemical sensor arrays, RF switches, and also in nanotechnologies in the atomic force microscope. And the students get to learn how to do data acquisition and graphing because they take a video using their video camera or their digital camera, and they do frame-by-frame analysis and determine what the resonant frequency of that is. And that's always a lot of fun doing that conversion. Teachers always have a problem with that, so it's good for everybody to go through that. Our pressure sensor model kit, this is the model we talked about a few minutes ago, but now we have a packaged part that's available, will be available by the end of the fall. You can hook that microsensor to a breadboard, amplify the signal if you teach electronics. You can measure the change in voltage as a function of pressure on the system. So you can do it as a macro model and then segue into the packaged part. And this is what it looks like, the Wheatstone bridge. So it's we actually fabricate these in our clean room. And now North Dakota is going to do the pressure sensor workshop for us in August, and they're learning how to fabricate it in their clean room, and hopefully Florida will also be one of our hubs down the road. Lift-off kit. This is a technique used to transfer patterns onto a wafer. Anisotropic etch. This is a lot of fun. You can actually etch silicon crystal in sodium hydroxide, which you can buy at the hardware store. And you get beautiful anisotropic etching, so that brings the crystallography into the fabrication of specific structures in silicon. And here we show that we've etched all the way through the silicon wafer, and you have a Wheatstone bridge that we patterned on the other side. And of course, we have a kit to bring the process into the classroom, so you don't have to have a clean room to teach pressure sensor processing. And that's a snapshot of what that kit looks like. Innovators is a capstone. So you design and build your own MEMS device out of craft materials and then explain what you did. And if you want to know more, come to our booth or go to our website. Everything's free, downloadable on our website. If you register as a teacher or instructor, you can get all the instructor guides as well. If you just look at it as public, or like you send your students to the site, they'll see all the student guides. So you can direct link into our student guides. Always have the latest and greatest version. We're a continuous improvement philosophy, so we're always updating and improving our materials. Did I finish in time?
Perfect.
Oh. No taser. That taser threat is very, very, very good. How do you move it? This button to advance.
Okay, good morning, everybody. I am Abraham Michelin. I am the executive director of the HI-TEC Center, Northeast Advanced Technological Center in upstate New York. We are located in Troy, New York, in the capital region of the state. And this center was basically created and because in the upstate New York, in the capital region especially, we have been seeing a boom in semiconductor nanotechnology industry that have been going there to produce a product like MEMS and things like this. Okay, so we applied for a NSF grant based on the fact that the industry needs a lot of technicians. And in upstate New York, we didn't have anyone. So the center was approved basically on that. Let me just give you a 2-minute history only, and then I will tell you what we are doing, because we have only 7 minutes. This is the purpose and the mission of the center. Basically, we want to create a center for nanotechnology and semiconductor in order to improve and increase the workforce in the state of New York, actually also in Western New England as well. So these are some of the goals of the center. Because we are geared toward the industry, you can see that we are trying to create the workforce based on industrial needs. Okay, for example, we have here we have a lot of experiential learning. Where we have a student and technician going to they go to General Electric or IBM or Global Foundries to have shadowing or internships and things like this. And other things, outreach activities for high schools and teacher development as well. So how we're going to do this to create the workforce? Basically, here you have some topics. We're going to have faculty development, adoption and dissemination of material, partnership with other colleges and other centers as well, and communication, outreach, and things like this. Okay, and this is basically the short story of the center. You can see that some facts about the capital region in upstate New York. You can see that since 1997, the area have been seeing a boom in new companies looking for technicians and creating new jobs in the area. For example, we have the SUNY Albany Center for Nanotechnology, which it is an incredibly big facility, probably the biggest facility of nanotechnology in the whole world for education. And they are looking for 1,000 people, basically. We have over 200 companies doing research and development over there. Also, we have companies like Tokyo Electron that came to the area. General Electric just invested in a $100 million battery facility. And probably the biggest player is Global Foundry, which is a spin-off of AMD, as you may know, where they are right now finishing building the fab, and they will need 1,400 people for 1,800 technicians, which we cannot provide them right now, 400 engineers, and so forth and so on. Actually, last month, Global Foundry requested from the state to build a second factory of the same size in the same time. So you can see that what we are going to do. Now, what we normally we are going to do, and we are doing it right now. Remember that we have only in business for only 10 months nowadays, but we are copying some of our friends like NAC. We are going to create a 6 course of capstone in order to cater to the high school students in particular. And we are going to model this based on the Penn State model as well. We are going to start instilling in the mind of young people in the high school about nanotechnology and semiconductor. And we are going to create some kits as well. For example, we are about to create a PV technology kit that we are going to distribute to high schools as well. Okay, 2 minutes. One of the things that we're going to do for the industry in particular are a lot of workshops. For example, we learned from Global Foundries. We made a survey of high schools, surveys of community colleges, and Global Foundries found that the education in electrical technology and semiconductor technology lacks the skills of, especially in pneumatic, hydraulic, RF, and SPC as well. So we are going to create some of these workshops. We are already working with Mohawk Valley Community College to create an automation system and RF system workshops. We are developing right now a solar fabrication and also workshop in semiconductor processes as well. How we are going to do this, and this is just 1 minute more. Basically, we are going to work together with the NAC Center in Penn State and HI-TEC, and also with the MEM Center in New Mexico, which is not here, but we're going to work with them in order to not to reinvent the wheel again. So we are talking with Bob. Bob will go there next week to talk about some of the courses development. We are going to use some of their material and content in order to create this. And for the high schools and community college, we are using especially all the modules of HI-TEC, which they are very rich in knowledge and technology. So, and then we are going to use also material from the MEM Center in New Mexico. Okay? That's it.
Thank you, Abe. So you've seen real smorgasbord of resources this morning. So whether you're a community college interested in bringing nanotechnology into your physics classes or developing a full-out AAS or AS nanotechnology program, you've got this spectrum of resources. So let me now solicit some questions from the audience. You've seen presentations from these centers that have these resources. What questions might we have at this point? How do you get this stuff? I asked Matt if it was free. He said it was. I was surprised. He always gives the same answer. We're going to start charging someday, and then he never does. So we ought to take advantage of him. What other questions do you have? There's a question in the back.
In your educational material somewhere, is there information about what students can do after they graduate, jobs that they might be able to get, what kind of jobs what kind of titles these jobs might have, and educational programs where they can go? Because if they take a course from me and what do they want to actually get degree in it? And secondly, I think Dad mentioned Nano Link, is that right? Nano Link. Is that a web address? Is that different from the other address, or?
Let's take those two questions. And for the people that we're streaming this to, the first question said, is there a place that I could send my student that they could see the wealth of opportunities out there so that it'll help encourage them into the program? So do you have something? I'll turn to Deb, and then you'll answer the second question as well. So face the camera.
Okay. First, in reference to students and knowing what type of careers, one of the best places to go is the Nano for Me website. There is a student tab on there, and it talks about what NAC has done as the National Center is not only taken alumni that have graduated from their program, but also alumni that have students that have graduated from programs across the United States. So Dakota County Technical College, North Dakota, has students that are graduated. On that website, you can see the 30 different job titles that our nano program graduates have. So it's not just there's nanotechnology technician isn't the only job title. There's also stories and interviews from alumni, what they're doing, what types of jobs they're doing, the benefit of the education. It's a very strong resource for not only students. One of the things that I've learned is you don't just necessarily have to convince potential students to get involved in nanotechnology, but you have to convince the grandmas, the dads, the moms, the grandpas, and the friends in college. And so both NAC and the NanoLink website have information about jobs, what type of job classifications, quotes from industry, quotes from students, stories about students. But the Nano for me is like the focal point in the United States for information for potential students about jobs and also to serve as the alumni network.
And the NanoLink website address?
The NanoLink website address is nano-link.org.
John.
Pardon?
So you would like to hear examples of...
Okay, I know that. Okay.
Two examples.
Okay, wonderful. A lot of my program graduates are serving as a member of a research or product development team. That means that they are working with engineers and researchers as they develop products, either at developing coatings at companies like Medtronic or Boston Scientific in the biotech, or at 3M. I have 12 of the program graduates from DCTC that are working at 3M. They are all working as part of a research team, so they are the ones that are responsible for doing a lot of the experiments using atomic force microscopes, scanning electron microscopes. So that's one batch. The other batch, it's really interesting. I'm trying to guess, 20% of my graduates that are in jobs are working for small, very small companies. 2 of my graduates are employees number 3 and 4 at a company that is developing nanoscale inks. And the benefit of working, or the benefit to a small company of our students, is they've got a broad understanding of lots of different technologies. They can do a lot of things. They are a jack of all trades in a very positive sense. There's a small company where one of the graduates, they're doing biological coatings. One day they're working with an AFM, the next day they're working with a nanomechanical indenter, the next day they're growing cultures. And a nanoscale program can train students in all of those. So they're either really small companies or great big ones like 3M and Medtronic.
And so it's 9:30, we're perfectly on time, and the session will now close. But I invite you to meet with us either right out in the lobby after this, down at the 10 o'clock to 2 o'clock exhibits. All of the 5 centers are exhibiting there, including the Premier Center, Maytech Networks. Excuse me. So you've seen a lot today of what's there to offer. Take advantage of it, but in particular, talk to us and see how we can enable your nanotechnology initiatives. Thank you very much for coming. And to those online, thank you. Goodbye.